pairs of points. It's going to use the ordered pair 1, 6, and 3, 54. And we're going to write 3 different equations that go through those 2 points. The first one is going to be a linear function. This is going to throw it back to Algebra 1 for you. Now, if we're writing a linear function, that's normally in slope-intercept form. So it just happens to be, I did not put this up here for your class. This is up on my board for Algebra 1A, but it was a good coincidence that it's there. Y equals mx plus b. What's the m stand for? The slope, and the b is the y-intercept. Now, do I know the y-intercept right now? No. Do I know the slope right now? No, but I just happen to have my slope formula right here on the board. So let's calculate the slope for this line. And don't stress if you're like, oh, slope formula, I don't remember. I'm not testing over this. We're just reviewing. Which y value do you want to write first? 6 or 54? Okay, let's do 54. Now, if you look at the formula, it says minus the other y value, which is 6. Now, if I use 54 as the first y, what's the first x you have to use?
3.
The 3 right here. So do 3 minus 1. All right, put on your arithmetic hats. 54 minus 6. 48 divided by 2 equals 24. That's your slope. It's a pretty steep slope, but that's your slope. Now, I know the slope, so I know the m. We already said we don't know the y-intercept. So there are 2 options, and you guys can tell me which one you prefer. Would you rather use slope-intercept form here and solve for b, or do you want to use point-slope form? Solve for b. Okay. I can tell when I teach your class that you guys had a teacher that did that a lot, because Algebra 1 at Hayes, we always do point-slope form. So it doesn't matter. It's all the same to me, but that was Mr. Bricker did always solve for b. That's fine with me. All right, so here's what we do. Pick one of these 2 points. Which one do you like better? 1, 6. Okay, smaller numbers are always good. So I'm going to use that 1, 6, the x and the y there, in this y equals mx plus b form. So which of those numbers is going to go in here for y? 6 equals, what goes in for the m? 24, my slope I just calculated, times the x value from that same point, 1, plus b. All right, now all I have to do is solve for b. 24 times 1 is really easy. That's 24. So I subtract it from both sides. And what does b end up being? Got it. So what's your equation? What's the final answer? All right. Here's your equation that goes through those 2 points. Taking it back a couple years. Now what I have here is that's the equation of that line. I know, it's great right now. It'll make more sense why I'm doing that in a few minutes. There's your line. Let's look at the exponential. This is taking it back just a couple of months. We wrote an equation through the same, bless you, 2 points that went through this formula, y equals a times b to the x. Who remembers what you're supposed to do here? It's okay if you don't. What's up, Kayla? What do you do?
So you
Go ahead.
both of them in, and the one with the higher one, you write it up.
The higher what?
The higher x.
Yes, the higher x.
Yeah, you write them down both and then line.
Okay, good. So she's saying put the x and the y values into this general formula because we don't know the starting value or the growth rate of the exponential. But she remembered that I suggest you always put the higher x value on the top equation. We're going to make a system and a stack. So let's use this ordered pair first because the x is bigger. So 54 in for y equals, and we just wrote a times b because we didn't know the growth rate or the starting value. And the x there is 3. Coming back to you a little bit. So what do I do with 1, 6? Tell me what to write down here.
6, and then maybe 1.
First. Now how do I solve this system? Divide straight down. So you're going to divide down the system every term. What's 54 divided by 6? 9. What happens to the a's here? They cancel. B cubed over b to the first? Then I get b because I can take the square root, and we're going to not do plus or minus here. We're just going to assume it is the positive square root, which is 3. All right, halfway there. I have the b, but I need the a. How do I find the a? Choose a point. Which point do we want to choose? 1, 6? Okay. So we're going to use that x and y in here along with the b that we just found. So we'll put 6 in for y equals a times b. Divide by 3, and what's a going to be? 2. All right, so far so good. So I have y equals 2 times 3 to the x. Remember doing that as well? All right, keeping it kind of in your brain. So here's what happens. I'm going to make a graph of that here on Desmos. What do you notice about those two graphs? They both cross, and it just happens to be they cross at the same points. So we did that on purpose. I wrote both equations through the 2 points. That's what they both look like. So now we've done linear, we've done exponential. Let's talk about quadratic functions. Now we've been doing quadratic functions so far only in vertex form. So we have a times x minus h squared plus k. So we're going to focus on just vertex form for now. How do I take those 2 points and then write a quadratic equation in that format? Okay, so there's some steps over here. I'll talk about the steps, and I'm going to kind of do the problem as we go. Or do the problem, and then the steps will be explained as we go. So I have 2 points. Now this time, it's a little bit more specific. It says the vertex of this quadratic is located at 1, 6. So that point in particular is the vertex. And it goes through the point 354. Now here's the thing. We need to understand what all these letters in vertex form do. The x and the y, those are just variables. The a is going to be a leading coefficient. We'll talk about what that does on Friday. The h and the k, what feature of the parabola do the h and the k make for you? The vertex. Well, I know the vertex, right? So that 1 and 6 are going to be my h and my k when I write my equation. And then this other ordered pair, what letters do you think they're going to go in for in this formula? X and y. So let's write the equation. What's going to go in here for the y? 54 equals. Now, don't put anything in for a. That's what we're actually going to end up solving for, that parameter. What's going to go in for the x? 3. Now, it says minus h up here, but remember, that just means the opposite of the x from the vertex. So what's that going to be? Minus 1 squared. Now, when I do the k part, is that the same sign or the opposite? Same. And now you just solve it for a. And this is actually going to be faster than the other 2 methods. I would subtract 6. What's 54 minus 6 again? 48 equals a times 2 squared. 2 squared is 4. So if I divide by 4, what is a? 12. I'm going to try to squeeze it in over here. That's actually all I have to do to get my vertex form. Y equals 12. And then tell me what's going to go in the parentheses. Squared? Got it. That's vertex form. Easy, right? It seems like it should be more complicated, but it's not. So that, when you look at the picture here, we make it zoomed out. Oops. No. There we go. Oh no, what did I do? Here we go. Sorry. There's the green one is your parabola here. Still goes through the 2 points that we wanted. Good. All right, flip your page over. So you can choose. Would you like to do problem A or problem B here on the back? A? Okay, we can do A. We'll do A, and then we'll do the last one there before the practice. So I wrote vertex form again. This time we know we have a vertex at 0, negative 6. So that's going to be your H and your K. And this equation is going to pass through the point 3, negative 24. Those are your X's and Y's. All right. So how do I write? Tell me what to write. So let's start everything off. What goes in for Y? Negative 24 equals, I don't know A. Then what? 3. And then I have a 0. Do I have to write 0? I don't have to. I'm going to put minus 0 just for now, just so you see that, like, that's the x coordinate of the vertex. But if it's 0, you don't have to write anything. And then my k, what do I write on the end? Plus or minus? Minus 6. Okay. And you solve it. So we're going to add 6 to both sides. And what's on the left here? Negative 18 equals a times, that's 3 squared. And I just divide by 9. So a is negative 2. So let's see, y equals a times, do I have to put the 0 in there when I write vertex form? No, so I'm just going to put x squared. You don't even have to put parentheses if you don't want to. Minus 6, and that's it. All right, not hard, right? Let's do one more. Let's do not B, let's do example 3. So actually it says here to write the equation in standard form. Now who remembers, we talked about this yesterday again. What is standard form? Ax squared plus bx plus c. So that one has no parentheses. But in order to get there, we have to do the vertex form first. So let's do the vertex form real quick. And we'll wrap it up here. All right, so we know we have a vertex here. This is my h and k at negative 7, negative 12. And my ordered pair I'm using for x and y is negative 2 and 13. All right, so let's see. 13 is my y equals a times x is negative 2. What do I put in for h here? Plus 7 squared. And then k is minus 12. Yep. Lost where I was looking. All right, so I add 12, which would be 25. So I get 25 equals a times 5 squared. That's going to be nice. What's a this time? 20. Well, it's not 25. What's a? 1. All right, so my vertex form, do I have to write the 1 on the outside? Nope. So I can just jump right to x plus 7 minus 12. All right, well, how do I go from that? I think we did this yesterday. What do I do? No, we don't have to do complete the square, but we did it at the beginning of our notes yesterday. How do I get from that to no parentheses? Yes, we're going to expand the quantity that's squared here. So we're going to rewrite that as x plus 7 times x plus 7. So we're going to have to double distribute there and then combine like terms, and then we're done. So FOIL, double distribute, whatever you like to call it. X squared plus 14x plus 49 minus 12. And what is 49 minus 12? 37. So the reason I'm teaching this year is this is actually the first year I've taught this lesson, because next unit, after we finish this one, we're going to do a bunch of quadratic modeling, and we're going to be writing equations of quadratics for different scenarios and real world situations. And we did this last year within that unit, but I thought it'd be easier to do it if I taught it to you ahead of time. So we'll just go faster next year. Cool. All right, 3 problems at the bottom. Give them a shot. A and B, they want you to